Two things. First, we're going to start by quickly looking at the different topics that we went through in momentum. Okay? We're going to talk about momentum and impulse, elastic, inelastic, momentum, and then energy all together. So we have four major things we looked at. Now, your problems that you were supposed to work on over the last 2 days, okay? I hand wrote the solutions for you and photocopied them, so you can go over on your own time, because I want to do new problems today in class. So we're going to do about 4 problems today in class after we go over the topics. This is what you're going to read over the next 2 days to check your answers. I wrote actually all the words and stuff, everything, like explaining what to do where. I put a lot of different little notes on stuff. Make sure you read through this with your homework to check. This is what you were supposed to do in the last 2 days. Now, what I want to do today to start again is go over the topics and then go through some different problems on here that are a little bit more challenging. Okay? There were some 2 or 3 that are a little more challenging than your homework that I really want to get to. Your test, same format as always. Multiple choice, short answer, free response. More free response than anything. Okay? More than anything, it'll be free response. Because we haven't done too much with multiple choice in this topic. It's been mainly word problems that we've been looking at. Okay? So please keep that in mind. A lot of people struggle with free response. Tomorrow's test will be more free response than other ones. Please keep that. Yes, tomorrow. Friday. We did.
We did? Yeah, we did. I was complaining about it.
Number 6, please. Number 6. Now, can I get a reader for number 6, please?
Yes, that was 3. That was 3.
I'm not going over the homework. I'm doing new problems. You will get the homework answers at the end of class. You can look at them on your own.
I want to read it.
Thank you, Elizabeth. Pause, Houston. Go ahead, Elizabeth.
It's on this one, right?
Yes, number 6.
95 kilogram half-fast moving at 4.1 meters per second on an apparent breakaway for a touchdown tackle from behind. When he was tackled by an 85 kilogram cornerback running at 5.5 meters per second in the same direction, what was their mutual speed immediately after the tackle?
So, everybody, here's what you need to picture. A train going this way, another train going faster, and it locks in. Remember they're together afterwards?
Yeah.
That's what this is. Remember the other day we talked about modeling and engineering with the gun package? Okay? This is modeling. You have a running back running at one speed, you have a cornerback that's catching up to him, eventually he tackles the guy. It's the same as the trains. One train is moving, the other train is catching up, eventually they click in and they're together. It's the exact same problem. So when you do these problems, you need to set up a model in your head. So when I see this, this is what I think right away. They're both moving that way, and then afterward, they're connected moving that
So
way.
you add both.
Okay, so this is before,
M1 V1 plus.
and that's after. Okay? Now, from your lab, most of you guys know the formula already. You could solve for VF. Look at your lab on the front page. On the front page of your lab, on the upper right side, you're going to see a formula that says VF equals M1 V1I plus M2 V2I all over M1 plus M2. That's the formula we're going to get. The upper right, guys, the right formula. This one right here. Okay, this is the one you're going to be using right here. And you can derive it. Let's show how it comes about. So we got M1 V1I plus M2 V2I equals M1 plus M2 quantity times VF. Again, look at the situation. This object has momentum. This object has momentum. Afterward, they're together. How do you show 2 objects together? With a plus sign. The sum of the masses shows that they are linked together. At this point in time, you're solving for VF. So divide this side by this quantity here. M1 plus M2. Divide both sides by that. And if you look at your lab, one of your formulas says exactly this. Except you had a little apostrophe here, a prime, instead of a VF. This is the formula from your lab. That's where it comes from. Okay? We did this in class. If you looked at your notes from class, we did this exact example, and we derived this formula. That's where the lab comes from. So again, at this point, just plug in. Plugging in, you're going to have 95 for the first mass, 4.1 for the second for the first velocity, 85 for the second mass. So the cornerback is a little bit lighter than the running back, which makes sense. Think about football. A running back is not very big, but a running back is usually bigger than a cornerback. A cornerback might be taller, but a running back is always bulkier. Think about like a guy like
he's
Brandon
shorter,
Jacobs,
right,
okay?
he's shorter.
They're short and they're stocky guys running backs. Whereas the cornerbacks need height to deflect passes. They're usually skinnier. Here's the cornerback, here's the running back. The running back, though, does not run as fast as the cornerback. Usually cornerbacks are the fastest guys in the league. Right, wide receivers and cornerbacks are your faster runners. So here, the velocity is 5.5 in the same direction, so it's still positive, all over the sum of both, 95 plus 85, or vice versa, doesn't matter. When you solve this, you end up getting 4.76 meters per second. Okay? Adolfo.
Is this kind of like the video that actually would help us
This is your VF, right?
where it shows the whole thing about how far we're doing
This is your VF, right?
Yes,
Yeah.
the video you put, did they collide and stay together afterward, or did one hit and they bounce off? I forget which way it
I
was.
think it was that one.
If they collided and landed, like tackled the guy, then that's what it is, exactly. But if somebody hits a running back and he keeps running, it's like a pool ball hitting and bouncing off. They're not sticking together,
Okay.
okay? If you get tackled, it's like when they
So
stick
this is not
together,
even that hard.
okay? Why are my units meters per second? What am I looking for?
Velocity.
Velocity.
You said this is the same formula as what?
When the two trains, oh, on the left, right here. Look at that formula.
And this
Look
is,
at
but
that.
it doesn't say if it's, it's,
This is VF, remember? We call it
it
V1,
doesn't
2,
say
5.
that it's in the line. You said the problem tells you. Yeah, that's.
If the problem tells you something, then you might have to pick one. If not, you just set up your equation to start. You don't have to memorize that formula. I don't want you to memorize that formula. This is what you need to know. You always have a balance of momentum. So if you set up this formula here, you're going to get that formula from me. So you don't need
It
to know it.
doesn't say it's inelastic or elastic.
That's okay though. It doesn't matter for now. Again, guys, if you're only given information about the velocity before and after, and you're given a problem where it's conservation of momentum, you don't have to worry about it being inelastic or elastic. Okay? Later on, if you're talking about perfectly elastic or perfectly inelastic, that's when we use that other formula that I gave you in class, where it was like V1 minus V2 equals V2 plus V1, that whole thing. That's when you need to know whether it's elastic or not. For this problem, conservation of momentum. Okay, set up your conservation, which is the first line, and solve the formula. Let's go to number 10. Reader for number 10.
Read it again.
Different reader.
Jason.
You don't like it?
Jason, go ahead.
Feel like you, we're not even like you for this.
Jason.
3,800 kg open railroad car coast along with a constant speed of 8.6 miles per second on a level track. Snow begins to fall vertically and slows the car at 6.5 kg per minute. Ignoring friction with the track, supports the speed of the car after 90 minutes.
Okay, now here's where we use logic, and we stop for a second and say, forget math, use logic. The car is filling up with snow, isn't it?
Yeah.
So at the end of it, is it going to be heavier or lighter?
Heavier.
Heavier.
If it's
Now,
base, like,
please answer correctly, guys. Don't joke. This is your mass ahead of time. This is your velocity ahead of time. So, afterward, it's going to have a mass that's something bigger. Okay, we don't know what that number is just yet, but we know that it's going to be a number greater than that. What do you think will happen to the velocity?
It will
Slow down.
It'll slow down, so it balances, right? If you get heavier, you're going to slow down. Think logically. Now, the question becomes this. They give us a rate at which the snow is falling. The snow is falling at 3.5 kilograms per minute. After 90 minutes, how many additional kilograms are added to the car? That's what you have to think about.
That's a change equals.
So multiply by 90 minutes, so the minutes cancel. Okay, this is a rate, 3.5 kilograms every minute. 90 minutes have gone by. So multiply these two numbers. It's like saying, I can walk 1 foot every second. So after 5 seconds, I walk 5 feet. I multiply 5 times 1. If I can walk 2 feet every second, and I go 5 seconds, then I've walked 10 feet. 5 times 2. So this is falling 3.5 kilograms, that mass, every minute. But 90 minutes have gone by. So take 90 times this number, and you're going to see,
315.
what do you get?
315.
315 additional kilograms. Very good. So this mass is no longer 3,800. It's 3,800 plus 315, whatever that comes out to be. 41.15. Again, that's why this problem is tricky. Because you're using momentum, but you also have to use common sense here. Okay, if you travel at 40 miles an hour and 2 hours go by, you go 80 miles. Again, if you travel 40 miles an hour and 2 hours go by, you travel 80 miles. 40 times the 2. Same thing here. It's the exact same thing. You have a rate of change or a secant a secant for pre-calculus. If you want to think from calculus, it could be a derivative if it's
I wanna think
instant.
about
It could be a secant if it's over a long period of time. Times a 90-minute time interval.
The idea
Now,
right?
I know the mass before,
So you add.
velocity before. Mass after, we have to find the velocity after. That's all it's asking for. So here's your equation. mv equals mv. This is I, this is F. Okay, what is this m? This is the first mass. This is the second mass.
So is this like,
It's just a balance. That's all it is. Okay, you're just balancing. Momentum before equals momentum after. Remember in the lab how it kept on asking for P total? And you could have set that equal to before or after? P total could have been before or after. That's what this is saying.
so momentum is mass, or mass after?
This is momentum earlier equals momentum
Oh,
after.
that's,
Okay?
but you're saying.
Momentum before is always equal to momentum after. Conservation here, guys. Conservation always. The momentum beforehand is this mass times this velocity. Now it's got a bigger mass, so it must have a lower velocity for it to balance. Okay? So please solve for VF here.
Divide by M.
Okay, so VF is going to be 3,800 times whatever the velocity was, which was
8.6, you said?
8.6, yes, all over the sum, which is 4115. Remember, M2 is the combination of these guys right here. That's M2, the mass afterward.
You might have that extra step.
So this is a hard problem because you know why? You really only have one object. Where's the second object, though? The snow. The snow is the second object, believe it or not. Okay? It's like taking an object, moving, and you just drop a weight in it. The second object is the weight, and it adds an additional mass.
It's not that.
Hold on, Ken. What do you get for VF? 794. And that makes sense. It has to go down. It was 8.6, and now it went down. It's got to go down because the mass went up, like we said a minute ago. Yes.
Would you use the like the derivative to find the rate at which the snow falls off the car? Because
Because of the velocity,
yeah, I mean, because also it has to put like
you'd have to know how fast it was leaking at what setup, and you need a lot more info.
No, I
But this
know,
could
but
turn into a related rates.
yeah, but I'm just saying. Yeah, I know they would have to give you like a certain rate that it would fall off.
Exactly. Know the shape of it, all that stuff.
Well, like a summer day and like
Snow is melting at this rate. Yep. Yep, absolutely. Absolutely. You also got to know the fact that snow, a foot of snow is like is an inch of water. So then you have a volume of water based on the snow, and you have to convert stuff. That gets a little tricky.
That's right.
Let's look at number 16, please. Okay, number 16. Can I get a reader, please? Adolfo, go ahead.
Eight.
Okay. A 12 kilogram hammer strikes a nail at a velocity of 8.5 meters per second. And comes to the road 3 times
Milliseconds. 8 milliseconds.
A, what is the equal distance to the nail? And B, what is the average force action?
Okay. Now, we've got a 12 kilogram hammer striking a nail. So it has an initial speed of 8.5. That's the hammer speed. It hits the nail, it hits the wood, and it stops, comes to rest. So again, VF is 0. VI is 8.5.
So this is. We gotta get. We have time. We have to.
The mass is 12 kilograms. The time is 8 times 10 to the negative 6. No, negative 3.
Oh yeah, I've been to ask you. What is
Remember,
that?
milli is negative 3. Milli is negative 3.
We have to E to the. What does that mean?
Same thing as this. If you had e to the negative 3, it means this. You move it 3 spots to the left.
It's like it's the time.
Scientific notation. E means the 10. Negative, move left. Positive, move right. So this is really, okay? That's what that really is.
Yeah, why can't you just put that?
Why don't you why?
It's much simpler.
What I do all want.
It gives it in milliseconds.
Gives it in milliseconds, sorry.
Are you
Guys, look at your units, please. It says 8 milliseconds. A milli is 10 to the negative 3. Like a millimeter.
Yeah, I just think logically.
Well, you could just write that. I'm trying to show you the steps. That would be nice. I would just write this myself, yes. That's what I would start with. Okay. The first part says, what is the impulse given to the nail? The second part says, what is the average force? Remember, F delta T, which is impulse, equals M delta V. This is our impulse equation. Okay, you don't have to memorize it, you'll be given this one. Again, you're going to be given M1V1 plus M2V2 equals M1 and M1V1 equals M2V2 with initial and final. You'll be given that last formula we had on the last page. So you do not need to memorize, well, you need to know that these are lumped. What you're going to be given is that this plus this equals M2V2 plus M1V2. Okay, or M1V1, whatever it is. You'll be given bounds.
The one on the left?
Yeah, the one on
The one that we've written like 25 times. I'm not going to write it right now. Okay? We've written it like every single time we've derived anything. You'll also be given this. This is your impulse equation. Okay?
Impulse, we don't.
So impulse, this is impulse. Impulse is M delta V. You need this to find the impulse. We're going to need delta T. Sure we are, because later on it says find the force.
that over M V.
So, for part A, it says find the impulse. Impulse equals M delta V. Okay, remember, this is impulse right here. Just write the word impulse for
Just
now.
that side equals
Okay, this whole thing means impulse right here. Okay, impulse is M delta V. So, all they want to know is what is the impulse, not the force right away. So, finding the impulse, you just have to use this right here. M VF minus VI. Negative, remember. So here you're going to get negative, and I think you're right, 102 is the number I got. Yes. You're going to get, because the mass is 12, 0 minus 8.5. 12 times 8.5 is 102. Now, it's going to be 102 kgm over s.
Negative.
Now, relax, we're getting there. Why is it negative here, people? Why is it a negative impulse?
Because
the initial velocity.
Final velocity is zero.
Okay, because final velocity is 0 is fine, but logically,
Yeah,
logically,
It's slowing down.
it's slowing down. Very good. Imagine, you have a hammer. You take the hammer, you hit the table. The table slows it down. Doesn't it apply equal and opposite force?
Oh, apparently not.
Equal and opposite force means it must be negative. That's where the negative comes in. Now, that is part A. Try part B on your own and find the force. Use the other equation.
Hey, that worked out for you there.
All
all you gotta do is divide 0.6.
What? Huh? No, I haven't tried it yet. Hold on, let me check. 0.0. I'm gonna use big tables. My impulse is
So
back.
for
Fire rate.
there's no initial timer.
Wait, time? It's just whatever time what they are.
Force is when you're baby and you have to push it out. That's usually the
Cal,
problem.
you're taking notes?
Like how much force you get? Huh?
I haven't been paying attention to the past few weeks. I've been working on my pre-calculus.
The body's still forcing it out.
The doctor's forcing it to
Yeah, so there's force going in and force coming out. It's
Did anybody else get a negative?
What about, oh, we were on.
Force, hold up.
One,
Negative.
2, 7, 5. 1, 2, 7,
All right.
5.
Okay, again, we're trying to figure out what the force is here. We're trying to find the force, so solve for F, please.
You said 12750?
What do we get? 102? This was kgm over s. All over delta t.
Negative
10750.
127.
No,
12750.
12,706.
So, like.
Okay, please take a look at that, make sure it makes sense to you.
Negative input, negative.
You need to go,
We need to go over like.
you need to go,
So if you drop your phone, right, like face down, will your screen, like,
Oh, yeah.
it will? Yeah, it's like, oh, fuck up.
Yours can. You say optimization.
all you do,
I got that thick ass case.
I think I'm gonna
This one's pretty good too.
You gotta write the question first.
That one's big. It's like
Yeah,
Yeah, I know.
This is two cases.
Let me see.
It's two
Hold on.
cases.
It's a plastic case and a rubber case. Not basically, literally, it's two cases.
No, wait, for what?
Hold on.
Oh, you're right, you're right. You got
All right, now, remember people, when you look at this answer, look at your signs. It's a negative force again, because it's acting opposite the direction of motion. The hammer hits down, so what applies the force back? The table, okay, it applies the force and a negative. Anybody watch Jeopardy?
Yes.
Anybody watch last night?
No, 2 years.
There's a college championship right now? You watch it?
What?
Did you see the physics category? In Double Jeopardy last, so 2 nights ago, funny, so this is, the whole week is college championships. So all the college students come in, so there's students from, you know, freshmen, sophomore, whatever, from around the world. Put that away, please.
Oh, so how was the calculator?
Okay,
Oh.
please. The questions, 2 days ago, there was a math category. And you guys would have laughed how easy it was.
I saw that one.
College questions.
I saw that one.
The $2,000 question was this. I'm serious. It said that 0.6 it said 0.6 in one spot, and then it said something like this. And the question said the following: 0.6 can be thought of as 3/5. What is the fractional representation of the other put on the other screen?
2/4.
What is 0.66, everybody? 2/3, right? Maybe we wouldn't have gotten it. Never mind. That was the $2,000 question.
I'm paying attention.
Okay? Last night on physics, on the physics category, the $2,000 question was what is the study of objects moving? And the answer is mechanics, what we start learning here. That was the $2,000. The $1,600 question was this. A person pushes against the wall and holds a book up. What force does the wall apply back on the person? Normal force. Okay? It was all the questions, like every 5 of them. I think you guys could have gotten all of them actually. The other ones were even easier than that. It's really cool. I didn't record it, I sort of brought it in. Okay, now let's get to the tough problems.
You'd be surprised, Mr. Hal.
Put that away.
22. Here is where it's important about elastic versus inelastic.
His dad dropped the soda. And my phone was like, soda dropped his own soda, so he drank like that. I took that shit off, and it was dripping on me.
Son,
And
they
then she
gotta
was like,
let
it's
you waterproof your alcohol.
For number 22,
They call it a waterproof alcohol.
it's very important that you notice. It says perfectly elastic. Perfectly elastic. Underline that, please, in number 22.
I mean,
Okay?
there's no separation?
Here's what this means. Remember from class, we wrote this the other day. We did not derive this formula, I just gave it to you. This formula can only be used for perfectly inelastic. So this is one of those formulas that you do have to know. Okay? Again, this is used only for perfectly inelastic. Where did this come from? Who remembers?
So, pool
It
ball.
comes from.
Okay, the pool ball, but that's not the only thing.
Hockey.
Where did the derivation come from? Who remembers?
Perfectly inelastic.
Not guys, I'm not asking what examples. Where does it come from? 2 different questions.
Oh, didn't it come from the elastic ball?
Good, but where did it beyond that? You gotta keep going. This is
It came from
conservation of energy. Very good. Guys, write this stuff down in your notes, please. You should already have it there.
I did.
When we combined momentum and energy that day, we looked at momentum and energy. We got this formula, okay? This is when it comes from when you balance energy and balance momentum. The second formula you're gonna use here where's this thing out? This is the formula you were asking about a minute ago. This is the one that would be given on your test. Okay, this is just balance of momentum right here. Okay, the bottom one. This is given for any problem. It's always balance of momentum. Because it was perfectly elastic, we can use conservation of energy, which leads us to this one up here. And again, I gave this to you. I did not derive it.
You put 2 B's right.
Thank you.
How would you derive it?
So for that one, it won't be on a test. You have to know it.
For the second one here,
No, the first one.
the first one you have to know. That's for perfectly elastic. So you should write this down. Perfectly elastic. You don't know. Yes, you have to memorize.
Okay, that's what I mean.
This
So
is your
you can
general
know-
formula.
You can know what it is, just that people still give it.
The reason I'm not giving you the formula up top is because of this. You can always derive where it comes from. Okay, whenever you can derive something, I don't give you the formula. Whereas this, there's not a derivation for this. This was given. Okay? So you'll be given this on the test. You'll be given impulse on the test. This one you need to memorize.
We have a grade.
No.
I just got my report card too.
Look, if you want to look, guys, just type in Google, just type in derivation of perfectly elastic equation. There's a simple, like I typed in yesterday and it came up right away. All the steps are there, how it goes through.
I got like a B.
It's not in your textbook, that's why I'm telling you this. Okay, the derivation is not in your textbook. Alright. So we're given a bunch of stuff here. Can somebody read number 22 for us, please? Larry, go ahead.
Ball of mass of 0.440 kilograms moving east. X is
Come on, yeah, a little louder, and everybody else please be a little quiet. Go.
a ball of mass of 0.440 kilograms moving east plus x direction with a speed of 3.30 meters per second collides head-on with a 0.220 kilogram ball at rest. If the collision is perfectly elastic, what will be the speed and direction of each ball after the collision?
Okay.
Oh, wow.
So, we have to use these two equations, plug in, and we're going to solve this with elimination method. Remember from Algebra 2, okay, elimination method. We have to cancel our coefficients. So let's go ahead and start plugging in. Here's what I'm going to do. I'm going to plug in what I know up here first. I'm going to plug in what I know here, and I'm going to write those two equations over here. So we're going to plug in the m's and the v's. We know the mass of ball 1 is 0.44. So we only see that here. So that's going to go down here at the bottom. Okay, 0.44. We know that ball 1 was moving with 3.3 meters per second.
3.3.
Okay, 3.3. That also goes in here, though.
Okay, that's right then.
Okay, so again, I'm writing both formulas one at a time. Next. The second ball is at rest. The second ball is at rest. So there's no velocity here. That drops off, and this drops off. So just put equal signs now. Again, because the second ball is at rest to start, they drop off. Velocity equals 0 at rest. That's 0, that's 0. Drop them both off. Now on the right side, I don't know V2F. I don't know V1F. Those are my unknowns, so just list them, please. But on this equation, I do know the m's. So I can at least plug in for the m's. 0.44 V1F plus 0.22 V2F. Okay, again, I'm literally plugging in what I know and getting these two new equations. It's key that you notice that these drop off here, or else you're going to be like, what? There's a third variable? They have to drop off, or else it won't work.
Every time we said that, Brad, and if I see a V, just cross that.
Exactly. Now, in order to cancel with elimination method, the coefficients have to be opposites. Remember.
Okay,
So see how this is a negative 1 here in front of here? This is a positive 0.44. Okay? I would multiply this whole equation up here by negative 0.44 so that these will cancel each other. Again, multiply this whole equation by negative 0.44 on both sides. Please multiply by negative 0.44 and rewrite it below it. And what you'll notice is that you'll get cancelings. They will cancel. So I'm going to take the result of that and write it down here. So I need to do negative 0.44 times 3.3. Negative, thank you. I had one with me a second ago too. Negative 0.44 times 3.3. Not 3, negative 3. Okay.
Negative 1.452.
I'm distributing this to everything. Remember, this gets distributed to everything. Everything in the whole equation. So this becomes negative 0.44 V2F plus, oops,
Minus.
what should I have done?
You should have done the opposite,
Why?
because in order to cancel,
You're right, keep going.
Oh, you should have did
It's
about.
already negative, guys.
Yeah.
It's alright. See how this is positive here? This is already negative, so just make this positive. Don't worry. It'll work. Okay? Again, just multiply by 0.44. Okay? Again, positive, please, not negative. Now, what you're going to notice is, once you've gone from this equation up here to this one, now look at these two equations together. Look at your V1F here. Its coefficient is 0.44. Look at V1F here. It's negative 0.44. So if you add these equations together, these will cancel each other out. Again, take whatever this turns out to be, this number, whatever it turns out to be here, add it to this number.
It's the same number.
Okay. It is the same number. Very good. So just double the original number there.
Coincidence.
Okay, so double, it's not coincidence actually. It comes about because of the coefficients. Since we want this value here, it's the only thing that's missing up here. So when you multiply it through, you get the same thing. It's not coincidence really, but for now, we'll say, look at that, that worked. So double this number, we're going to get 2.904 equals, now, again, when I add these two together, just cancel them. Because again, we're adding these two equations. Here you're going to get 0.66.
V2F.
Okay, then just divide by 0.66. Again, notice, these two cancel when you add these equations. It's like a big plus sign here. We're adding those equations together. Okay, when you add these two together, you get this number. When you add these two, they cancel. When you add these two, you get 0.66. Divide by 0.66, you're going to get 2.904 over 0.66. 4.4 meters per second equals V2F.
Oh, that works.
We need to find the other one by plugging back in, but again, this is 4.4 meters per second. Let's take a look. Our original velocity was, where are we? 3.3. Imagine now, this is how you can solve this one in your head. You've got a velocity of 3.3 with a very heavy object. Then there's a lighter object over here. And the bigger object hits the lighter object. It's going to shoot off very fast. Think about the example that it did in class. Remember the basketball, we dropped it? The basketball was very massive. The tennis ball was not massive. It dropped, it transferred all its momentum, and the tennis ball shot off at a much higher velocity. That's this problem. You start at a lower velocity for the heavy ball, it hits the lighter ball, and that shoots off at a higher velocity. So your answer makes sense now. Let's see what we get here. If you plug in 4.4, anywhere really, plug in 4.4 right here in this equation and solve for V1F. Again, plug in 4.4 right here and solve for V1F. It doesn't matter, but you have a system of equations. So whenever you get one solution, you plug it back in to get the other solution.
Mm-hmm.
Sure. Yeah, you know what? That makes it easier. I agree. Christian, you're absolutely right. Take the 4.4, plug it in up here. That's the easiest way to do it. So 3.3 and 4 is 1.1.
It's negative 1.1.
I think you get positive because this is going to be 4.4 right here. It becomes negative 1.1 equals negative V1F.
Yeah.
Again, we're taking this value, we're plugging that value in up here. We move the 4.4 over by subtracting, you get negative 1.1 equals negative V1F. If they're both negative, it becomes positive. Okay? Now, here's what I want you guys to do. One of those was in your homework, and that's what I'm going to exactly have you do right now. If you didn't get your homework done, and you want to try a problem like this again, the one in your homework that was like this, can you pull out your homework to see?
I never thought the other day when I had established Vegas, just for one.
The one from your homework was 24 and 27.
I remember I was in middle school.
Like,
I used to look at
later races, like,
Everybody.
I used to be in middle school.
24 and 27 of your homework is the exact same kind of problem. Okay, 27 and 24. Try them on your own. Give yourself about 10 minutes. When it gets to about 11:50, I'll give you the answers to check. Try 24, everybody. Try 24 on your own. Same kind of problem. Okay, same kind of problem.
I don't want to do this anymore. Here I am. Still saying the same thing over and over.
Hold on.
I want to be here, see.
I'll point out one thing as a hint. If you don't do this, the problem won't work out. See the second equation here? If all the masses were the same, what would happen? And in this example, for 24, all the masses are the same. So these are going to drop off. So you have this equation up here, and then just the v's from this equation down here. Those will be your two equations, the two unknowns. Okay?
Don't the masses drop off?
Again. Really?
Until
Did you hear what I just said?
Okay.
He said
So,
the master's drop.
Number 24, try on your own, see what you get as an answer. In 10 minutes, I'll give you the solution to look at. Okay? We're clear? If you finish 24, please go on to 27. Make sure you can do both of them. Again, you need to have this formula up top memorized.
So, but Mr. Howard.
And how do you memorize it, by the way? 1 minus 2, 2 minus 1. Again, that's all I think about. 1 minus 2, and this side is always initial.
Well, you're a genius.
2 minus 1, and this side is always final. So just remember 1 minus 2, 2 minus 1.
Never mind.
Okay, and you gotta put initial over here, and you gotta put final over here. Mm-hmm. No, I didn't. Thank you, sorry.
That was my question.
Okay, again, to reiterate, for tomorrow, people. For tomorrow. The whole topic is on momentum. We need to know the idea of conservation and what impulse means also. So you got momentum, conservation, impulse. The formulas that you will be given are as follows. You will be given the first one. You should know this by now. We've used that every time, so it shouldn't even be new.
So those are the only 3 formulas
Okay.
you're giving us?
You're given that one, and you'll be given this one.
Oh, you only giving us 2.
The easiest one.
Yeah, right.
Okay? Momentum and impulse. The only other formula we've ever used, we've used 2 other things mainly. One of them was the one with the ballistic pendulum. Remember we said that the velocity ratio for that one turned out to be square root of h2 over h1. We did that thing where the bullet is fired into the block.
Do we
The
gonna
block
need
goes
that?
a certain height up.
We're gonna need
Okay?
that?
This is in your, you might want to know this one. I mean, maybe you're problem on ballistic pendulum, so this might be one you want to know. Okay? If you look in your answer key I just handed out, the last problem was a ballistic pendulum. Look at the solution for that. The other one you need to memorize is the other one we used today, for perfectly elastic.
I can't tell that you
Okay?
Mr. How?
1 minus 2 equals 2 minus 1. That's how you memorize that one.
Can
For this one, the other one is just h2 over h1 with the radical.
Can P
Memorize.
total ever be negative?
Can whatever?
P total.
Yes, your delta P can be negative. Why? What are you getting?
I mean, I got a negative. The P total is this, right? Without the true half.